Hello Geometry, and welcome to 9.2 Special Right Triangles. This is an especially important section because it will stay with you in every math class where you have to do any sort of trigonometry. You've noticed that with Pythagorean theorem, the three sides of a right triangle are related in a very specific way. Well, we're going to look at two triangles where the angles of the triangle in a right triangle also determine some very special relationships among the sides. This is going to be kind of a long video, so you might want to break up the first page, take a break, then continue with the second page. On this page, we're going to look at 45 right triangles. So 45 degrees is what we're talking about, which, because these two angles are the same, that does make it an isosceles triangle. So what I'm going to do is I'm going to make each side equal 1. So those are the legs. And then using Pythagorean theorem, we want to come up with the length of the hypotenuse. And the reason why I'm going through sort of this derivation of the three relationships, or the relationship of the three sides, is so if you forget the ratios, you can derive it yourself. So all I've done is call each of the two equal sides 1. Then by Pythagorean theorem, 1 squared plus 1 squared, well, that's 1 plus 1, which is 2. And we know then we take the square root, so this side will be the square root of 2. That relationship is always going to hold. And we know with similar triangles and dilations that if you multiply each side by the same scale factor, we're going to use a scale factor of x, then that keeps the same ratio of the sides. So I have my 45 angle here, angles, and then I'm going to multiply each side by x. So this becomes x rad 2. And that is the relationship. So if the side length was 3, it would be 3 rad 2. Think of the conga line. 4 rad 2. 5 rad 2. That is the basic relationship in a 90 triangle. X rad 2. Now, that relationship can be manipulated. So let's look at a few examples. We're going to start with the easier examples. So again, it's 45, so I know that these two sides are the same. So x over here is going to be 5 rad 2. Over here again, now I sometimes like to, depending on the difficulty of the problem, I will sometimes write those ratios on the inside of the triangle so that I can make a relationship. So I know that x is 11, so down here I have 11. Over here, I know this will be 11 rad 2. And don't forget, you can always use Pythagorean theorem. If you know two sides, you can find the third side. Well, over here, now let's write those ratios on the inside. X rad 2. So I notice here that x rad 2 equals 23 rad 2. That must mean that x is 23. So you can sometimes solve for the unknown by letting the side equal its ratio. So we have x rad 2. So I know this side will be 4 rad 5, and that third side is going to be 4 rad 5 times rad 2, and this together becomes 4 rad 10. So that would be your hypotenuse. Okay. Now let's do a few harder problems. So let's start off with rad 6. Oy. So we have x rad 2. There's several ways I can go about this problem, but I'm going to show you a little trick. I know that square root of 6 is square root of 3 times square root of 2, which then makes the square root of 3 my x. So this will just be rad 3, and this will be rad 3. So sometimes if you can break it up like that, you can solve. Now here comes one of the harder ones, because this is always going to require rationalizing a denominator. We know these two sides are the same. It's a 45, 45. Now let's put those ratios on the inside. This was x, this is x, this is x rad 2. So what we're going to do is we're going to let x rad 2 equal 12. And our goal is to solve for x. So I'm going to divide both sides by rad 2. Well, that's nice, except you can't have a radical in the denominator. So we have to rationalize. How do you rationalize? You take what that radical is and we multiply by 1, because that doesn't change anything. It's kind of just converting it to a new format. So on the bottom, this becomes 2. So far I have 12 rad 2 over 2. And since I can simplify that, those will cancel. You can't ever go inside the radical, okay? If you're not in the rad club, if you're not under a radical, you can't talk to any numbers under a radical. But I can simplify outside, so x becomes 6 rad 2. So down here we have 6 rad 2 and 6 rad 2. Now a little shortcut for those of you who kind of remember the patterns. Because I had to rationalize with rad 2, notice you're always, when you have an integer on the side with the radical, you're always going to take half of that number times rad 2. Always going to be half that number times rad 2. Now look at this lovely number here, 9. Well, what I just said still applies, but you know what? Let's work it out. So this was x, x, x rad 2. We're looking to see what is x. So we have x rad 2 equals 9. We know we have to divide by rad 2. We know we have to rationalize. And although this cannot be simplified, I can then just write it. So like I said, it's always going to be half. So there's half of 9 times rad 2. So this is 9 halves rad 2. All right, so when an integer is on the side with a radical, it's always going to be half that number, whether you can simplify or not, times rad 2. All right, let's try a word problem. The length of the diagonal of a square, well, we know that a square has 4 sides and 4 right angles, and we have a diagonal here, and it tells us, so that also means these are 45, 45, because it bisects those right angles. The diagonal is 32, and they want us to find the perimeter. Well, we can use that little trick we just did. So we have an integer, whoops, sorry about that. We have an integer on the side that would be the rad 2 side, remember, because this is x, x, x rad 2. So if I take half of that, half of 32 is 16 rad 2, and that would go the same for all 4 sides. Since in a square they're all the same. So I have 4 times 16 rad 2 is going to equal my perimeter, which is going to be 64 rad 2. Now, if I took a liberty with finding that 16 rad 2, let me go back and show again. This is x rad 2 equals 32. You would divide both sides by rad 2. To isolate x, then you have to rationalize. So notice when you rationalize, it's always like dividing by 2, and half of 32 is 16. All right? Might want to take a little break, and then we're going to look at some 30, 60, 90. Okay, I thought I had finished, but it didn't record the last problem, so let's do this again. The body of a dump truck is raised to empty a load of sand. How high is the 14-foot long body from the frame, so we're looking for this side, when it's tipped upward by a 60-degree angle? So let's redraw that triangle. Here we go. They know that this is 14 feet, this is 60 degrees, 90, and this is going to be 30. So I know I can label the sides, x, x rad 3, 2x. So I know that x is going to be 7, because that's half of 14. And I know then this side will be 7 rad 3, and that's what we're looking for. So the dump truck will be 7 rad 3 feet high. Okay, I hope that helps. This is a really important section because it is going to stay with us the rest of the year, as well as every class that uses trigonometry.